This is another unique example of graphing a rational function where certain things don't exist. And I'm actually not going to do all of my 8 steps on this particular function once I notice a particular thing. So if I do start off by finding the domain, I know there that I would need to set the denominator equal to 0. So x minus 1 would be 0, indicating x is 1. X is 1 is the only value that could not be in my domain. So it would be negative infinity to 1 union 1 to infinity. As my next step, finding the x-intercept. So number 2, x-intercept. To find this, I know that I need to factor my original function and then cancel anything that would cancel. So the top of this I see does factor because it's the difference of squares. The bottom is already factored. Top is x plus 1, x minus 1. We can see here that those two factors would actually cancel out. So to find my x-intercept, I would want to set the numerator equal to 0, but only the x plus 1 factor. So doing that, I would get x is negative 1. So my x-intercept is negative 1 and 0. Third step is to find my y-intercept. The y-intercept is found by substituting 0 for x. So f of 0 would equal 0 squared minus 1 over 0 minus 1. This would be negative 1 over negative 1, which would be positive 1. So the y-intercept would be 0, positive 1. Step 4 would be to find the holes. Well, holes occur at values in the factorization that cancel. We know that our x minus 1 factor canceled, and so there would be a hole at wherever x minus 1 equal to 0. Well, that value would be at x is 1. So I know that in my graph I would need to leave a hole wherever x equaled 1. Now, I said that I wasn't going to go through my entire 8 steps, and here's the reason. We see in this example that if we factor and we cancel, we're left with x plus 1. Well, the original function f of x, if you reduce it, equals x plus 1 with the additional information that you have a hole at x equals 1. What kind of function is this? It's linear. It has a y-intercept of 1 and it has a slope of 1 over 1. What's the only thing I need to be careful of? I've lost information here, but the information I've lost there is that you have a hole at 1. That means that my function is going to be linear except for leaving a hole at x is 1. So I can skip all the other steps and I can go straight to my graph because of this unique situation of my rational function turning into a linear function except for at one point, which is the hole. So I'm going to come down and I'm going to graph, and we can see when we graph, and we're basically graphing the function y equals 1 over 1 x plus 1. It has a y-intercept of 1, and then it has a slope of 1, which would mean I'd go up 1 and over 1 to get to another point. And then if I did that, if I went backwards, if I went down 1, left 1, I would have my x-intercept, which I knew to be negative 1, 0. Okay? So if I graph through that line, it's supposed to be a straight line, then that would be this linear function. But I have the restriction that x cannot be 1, because that's where my hole is. And so what I would do is basically come up, we can see right here would be where x is 1. I'm going to come in and I'm going to erase that point and leave a hole there. And so that would be my graph. Now be careful, if you were to graph this on your graphing calculator, you're going to see just a straight line. Your graphing calculator isn't smart enough to find that hole that you had at x equals to 1. Okay, so be careful about checking this on your calculator. Even though it will show you that you have a linear function, it will not show you the hole.